This is AP Calculus AB. We're looking at the release free response question from 2004, question 5 from Form B. Consider the differential dy over dx equals x squared times the difference of y and 2. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. Note the axes provided. Use the axes provided in the test booklet. Well, let's see if we can figure out some patterns here to make this easier on ourselves. For example, if I were to put a 0 in for x, doesn't matter what this is, 0 times anything is going to be 0. So that means on the y-axis, the slope has to be 0 every place. 0, 0, 0, 0. I like to get my zeros out of the way at the beginning. For 1, it seems pretty easy. 2, it builds my confidence. I like having my confidence built. Well, when could this part be 0? This part would be 0 whenever y was 2. So it doesn't matter what x is. If y is 2, we're going to have the slope of 0. Y is 2 here, and it's 2 here. So that's easy enough. If you had done that part, and that part alone, you would have got 1 point for this problem for just getting the zeros correct. Now let's check out what if we did, let's do some ordered pairs here for these other ones. The patterns maybe not quite as easy. If I choose the y values of 3, well, let me sum up what I've done so far. I said if my x value was 0, my y value could be anything, and the slope's going to be 0. I said my x value could be anything, and my y value could be 2, and my slope's going to be 0. Keep in mind, what we see in this table, they're not going to grade that. They're just going to look at this. It's just for our help here. If I choose 0 for y, it's going to give me -2 in parentheses there. This is on the x-axis. And then because the x is to the 4th, it doesn't matter if I choose a positive or -1. I'm going to get the same answer. 1 to the 4th and -1 to the 4th. Those are both the same number, which is 1. So both of these cases, I'm going to end up with 1 times -2, which is going to be -2. So at the ordered pair, -1, 0, slope's -2. +1, 0, the slope's -2. What if we went to, let's say, the y value of 1, and we've already established that whether we choose positive or -1, it doesn't affect it, because a -1 to the 4th and a +1 to the 4th are both 1. And then a 1 minus 2, it's a -1. If you multiply those, you're going to get -1. So the slope at -1, 1 is -1. +1, 1, it's also -1. Then if we went up to the y value of 3, and the x value could be -1 or +1, we're going to get 1 again, and then we're going to have 3 minus 2. That's 1 times 1, which is 1. So this slope is +1, this slope's +1. You get another point for this one if you successfully had these blue things highlighted as positive and the red things highlighted as being negative. It's worth 2 points. Let's check out B. While the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are negative. Well, it looks like, so I hope you can agree, the x value isn't going to determine if something's positive or negative. It could determine if something's 0. So we don't want it to be 0. Let's get that out of the way. So the slope will be negative. First of all, as long as x isn't 0. If x is 0, then the slope can't be negative. It's going to be 0. What y values are going to make the slope negative? Well, if we wanted to show a little bit of algebra, if we got y is bigger than 2, if we want this to be negative, we would say y is less than 2. And if you look at our graph, that's true. Every time we're below 2, we're saying the slopes are negative. It's just going to continue. If I put a -3 in here, -4, -5, -6, it's just going to become a bigger negative number. So to finish answering this question, slope will be negative when x is not 0 and when y is less than, hold on one second. Yeah, when it's less than 2. I had written on my answer key bigger than 2, which doesn't make sense. And this is true for all values of x, y. Cool. That is worth 1 point. C, find a particular solution for f of x to the given differential equation with the initial condition 0, 0. So the differential that we were given was dy over dx equals x to the 4th times the difference of y and 2. We're going to separate our variables. I'm going to multiply both sides by dx. I'm going to divide both sides by y minus 2. On the left, when we integrate this, I'm going to set u equal to y minus 2. It's going to make du over dx 1, which makes du equal to dx. I'm sorry, I made a mistake there. This should be dy, not dx. Take the derivative with respect to y. On the right side, we can integrate this directly. Add 1 to the exponent, multiply by the reciprocal, add your arbitrary constant. On the left, we're going to have natural log of the absolute value of y and 2. It's easier on us if we now use the initial condition before solving for y. It's just algebraically, it's simpler. So we had the ordered pair f of 0, 0. So it's natural log of 0 minus 2 equals 1/5 of 0 to the 5th plus your arbitrary constant. That's natural log of -2 is going to be 0 plus c, which is c, of course. This is natural log of 2 equals c. So now we can say that natural log of the absolute value of y minus 2 is going to equal 1/5 x to the 5th plus natural log of 2. To get a particular solution, like this is going to lead to 1, could lead to 2. We want to get the absolute value by itself. This is currently in log form. We're going to change to exponential form. So remember, this base here is e. This is saying log base e of the argument equals this exponent. So in exponential form, it's e to the exponent equals the argument. This left side can be simplified more. Since this is natural log, that means that's a base of e, and this base is e, we want to separate this into a product. It wouldn't be the end of the world if you didn't do that, but I think it's something you'd want to do. E raised to an exponent that has a base of e, it's just going to become the argument. So this is just going to be 2 times the 5th x to the fifth equals the absolute value of y and minus 2. This y minus 2 absolute value business, this is two separate equations. We have a negative version, and we have a positive version. If we solve each of those, we're going to get 2 minus 2 to the 1/5 x to the fifth equals y, and we're going to get 2 plus 2 e to the 1/5 x to the fifth equals y. Which one of those, which equation we'll say, contains the ordered pair 0, 0? Honestly, I don't know an easy way to answer this other than just figuring it out. Excuse me. I mean, maybe you can tell right away that this one's going to be the answer. Let's talk through it, why that's the answer. If I put 0 in for y, that means this side has to be 0. If I put 0 in for x, that's 0 to the fifth is 0. A fifth of 0 is 0. E to the 0 is 1. That's 2 minus 2, which is 0. If I do the same thing over here, this thing is still going to become 2, because it's the same expression that you had here. It's going to be 2 plus 2, which is 4. That would be 4 equals 0, which is not true. So this is the one that works. As far as points go for this, you get a point for separating your variables correctly. You get a point for integrating each side correctly. That's 2 points total. A point for figuring out what c is, a point for using the initial value, and a point for finding the actual particular solution. Well, that concludes the 2004 released question number 5.